So today we're going to be talking about plate boundaries. These are where these plates meet. So when these giant plates come together, stuff happens. At these meeting points, there are three types of plates: convergent, divergent, and transform. We're going to get into that today. So the movement that occurs at the boundary between the tectonic plates determines what type we're having here. So the movement of the boundary is what's important. That goes in your notes. So, like I said, I bold, underline, or highlight things that you need to do. So in here, the type of movement that occurs at the boundaries between the plates determines it. Three major types of plate boundaries are convergent, divergent, and transform. Typing is hard. All right, there we go. All right, I'll post the link again. Okay. And remember, before we move on, I'm going to ask at every slide, do you need more time? If you do, go ahead and hit the raise hand button like that, because it gives me an audible notification, and I don't have to switch back and forth between screens. It just keeps things moving smoother. Okay. All right. So, does anyone need more time? Okay, thank you. All right. Next up. So the first type we have and we're going to talk about is a convergent boundary. A convergent boundary is when two plates come together. So the word, you can break it up yourself. If you think about it, converge means to come together. If you may have heard that word somewhere before. When people converge on a spot, that means they come together on the spot, or they go to the same place. Convergent boundaries do just that. They're also called destructive boundaries because they slowly destroy the plate that's sinking underneath the other one. The denser plate moves underneath the less dense plate, and it sinks and melts and becomes part of the mantle. So as you can see in that picture, the one sinks and is melted down into magma. Now that magma can rise up and crack through cracks in the earth and form volcanoes. Now, on your notes, you should only be writing down what's in bold. You don't have to copy down all of it. So you can just say, called destructive boundaries. Dense plate moves beneath the less dense plate and becomes part of the mantle. So that should be what you type in. For example, so you can abbreviate like I did. So the denser plate moves below the sinking plate and melts and becomes part of the mantle. You can shorten to the dense plate sinks under and is melted into the mantle. You can simplify. I'm okay with you doing that because it kind of makes your life easier. And you're still getting the main point across. What I care about is the main point. Does anybody need more time? Okay. The 3 lines are on the next slide. Okay. Get ready to move on. All right. So this is the first one on those 3 lines. Man, I got something in my throat today. So the first one is oceanic convergence. So that one goes here. So that's what you write, like just like I did here, oceanic. That's all. I just want you to know the 3 types because if you know this material, they're pretty self-explanatory. All this means is that when 2 plates converge and there's an ocean on them, that's it. So this just means that there are 2 plates made of oceanic crust. That's it. Oceanic, not very fancy or complicated. It's right in the word. Ocean. When 2 ocean crusts converge on each other, normally they form pretty deep trenches. Now these trenches are like exponentially deep. All right, we've never been to the bottom of one. There's too much pressure. There's nothing that we have that's man-made that can make it all the way to the bottom of a trench. So they have a lot of mystery around them, and they're pretty much unexplored. It's really interesting to think that we we've explored more of outer space than we've explored of our own planet. So we have not explored the ocean floor hardly at all because we can't get down there. It's hard, but we can go to outer space because we just take a rocket up there, and then we have spaceships and stations up there. But yeah, it's really hard. It's really hard to explore under the earth, the ocean, and this trench is so deep. So if you look, that one of them is off the coast of Japan and China, and it's over in the Philippines, or Philippines. It's right there. It's just a big bunch of ocean. So underwater volcanoes can form here too. So volcanoes form from cracks in the Earth's surface where magma shoots up from. So if it shoots up and it's underwater, then it's going to be an underwater volcano. The largest mountain on Earth is actually underwater. It's not Mount Everest. So Mount Everest is the tallest one above the surface, but there are big, big, big mountains underneath the water. So again, all you need to write down this slide is oceanic, oceanic, that's it. So I'm not going to spend a lot of time once I finish talking about these ones because all you have to do is write down one word. All right, the next one is oceanic, continental, and if you are following along, that makes sense. It's an oceanic plate and a continental plate that come together. So, oops. So that's all you have to write. So it's when an ocean plate and a continental plate come together. This is like the one we saw in the example on the first page, and it's a common one we will talk about frequently because that's where a lot of stuff, you would have mountains, volcanoes, earthquakes all at one point. So it's kind of like a hot spot for discussion. These can form large mountain ranges because, like, if you think of if you took like 2 blocks of Play-Doh and you smush them together, then they would kind of form upwards and form a mountain. That's where a lot of these mountains form. Now it's hard to think about because these mountains are huge, but in comparison to us, that's how they work. And the Andes Mountains are a good example of this. Right. And then finally, if you're following along the pattern, we have continental to continental. Okay. Oh, let me slow down. So if you look at my screen, I'm showing you what it should look like. So you're just talking about the 3 types from each of the past 3 slides. That's all I'm looking for. We're going to be moving into the divergent and transform boundaries later, but the 3 types of convergent boundaries are right there. Does that make more sense? Johnny and Amelia, did that help? Okay. All right, a couple more slides to go. The next up is a divergent boundary. So on these boundaries, this is where Earth is splitting apart. So what you should be writing down is stuff that's in the bold. And again, I encourage you to summarize so you don't have to write down every little word. Okay, so two tectonic plates move away. All right, so you guys are here. Move away from each other. You can write down also called a just constructive boundary. And so this last part, it says, as rocks move apart, molten rock from within the earth moves up and fills the space between the plates. Okay, so you can shorten that. As plates move apart, uh, magma fills the gap, hardens, and becomes new earth or rock. So that's how you can abbreviate it so you don't have to spend so much time trying to type out every word. Does anyone need more time? Okay. Let me know when you're done. Okay. Next up is a transform boundary. A transform boundary is where two tectonic plates slide past each other. Earthquakes frequently form at these boundaries. So you can think like if you've ever been in my classroom, I know not everybody has, but if you take the two desks and you slide them past each other, there's a lot of vibrating and shaking. That's exactly what's happening with these earth plates. When they move past each other back and forth, that means neither one is going underneath the other one or apart from the other one. They're just bumping past each other. These ones are the ones that cause a lot of earthquakes, and earthquakes are here. Let's see. They're often found between two convergent or two divergent boundaries. So go ahead and put this in the chat. Where do you know of a lot of earthquakes that happen in the United States? So where in the United States have you ever heard of earthquakes happening? You don't have to be right. Just tell me. Okay, California. Can anyone else confirm that? Where else do they happen? There's actually a lot in Alaska, but there's no one there to feel them. Only in California. So that's actually a really good point, and that kind of leads me to my next one. The San Andreas Fault is a well-known transform boundary, and it goes right through the heart of California. So California is a large state on the coast. It goes straight through San Francisco and gets pretty close to Los Angeles too. So you can see there on the picture on the right of like an aerial view of it, and it's a nice picture because you can see directly where that line is. It almost traces it out for you. So yeah, it's a pretty scary place. That's why there's so many earthquakes there, because it's right on a fault line, and that's why we never have earthquakes, is because we are smack dab in the middle of the plate. So all the action happens on the edges of these faults. All right. So in your notes, there is a link that takes you to this Plates on the Move website. In your notes is where I want you to go here, because if you go there on the Nearpod, when we're done with class and I close my Nearpod, it's going to close it for you as well. So make sure you go there in your notes, scroll all the way to the bottom here where it says exit ticket, planes on the Move game. So you're going to click on this, follow the link, and all the instructions are right there. So it says click on this game to explore our planet, examine the tectonic plates, and answer the questions to read more about it. So how we're going to do this is you're going to, when you click on these, so over here, I'm going to click on, you're going to answer all of these questions. So when I click on the plus, you're going to see arrows moving. All right, so you have the North American plate and the Pacific plate, and you can see them moving past each other here, left to right. So it says, which tectonic plate interaction caused this earthquake in San Francisco? So you're looking at all the ones that we just talked about: a slip, a collision, a spread, or a subduction. The subduction means to dot, like to go underneath. So you can see here that a plate's slipping underneath. So that's not what's happening here. The plates aren't spreading in opposite directions, and they're not coming closer together either. So they're slipping past each other, because that's what a transform boundary does. You click on it, it'll tell you got it right, and then it'll give you a short explanation about why it's right. And then if you're really interested, you can read more about it down here. Once you complete a target, it'll come up in blue. All right, so then if I want to do the next one, all right, Iceland, you can see that these plates are moving away from each other. So which activity is this? It's spreading, because the arrows are moving away from each other. And it'll show you this below. If you get one wrong, all right, it's important to look at where the arrows are going. All right, you can see these are slipping past each other, but say I got it wrong, it'll just tell you try again until you get it right. So when you're done, you're going to take a screenshot of your entire map. All right, so if you remember, a screenshot is holding down the Windows key, holding down the Shift key, and tapping S one time. It'll bring up a crosshair target. You select everything you want to be in the picture, and then when you let go, it'll automatically copy it to your clipboard so you don't have to do anything else. So I'd come here and paste it. Oops. Come here and paste. And it'll be there. So what I'm looking for is all of these to be complete. Every little plus, orange plus should turn blue. That's what I'm looking for in the picture. It's worth 10 points, and the rest of your notes are worth the other 10. So this is a 20-point assignment. And I'm looking 10 points for the notes, 10 points for the exit ticket. Does anyone have any questions before we go? Okay, so I will be posting the notes to this online here in a little bit. If you have any further questions or want to watch this again, I will also be posting a video on the YouTube page.